Good morning and welcome to this year's Potato Science Live series. My name's Gus Merrick. I'll be a chair for this week's webinars. So today we're covering blight management with Andy Cunningham and Harry Fordham. We've got two more events left in the series. So tomorrow, same time tomorrow, we're covering biostimulants in potatoes, and on Friday looking at sustainability. But before we make a start on blight management, a little bit on housekeeping. This event is being recorded. No one else has permission to record it. It'll be published on the Syngenta YouTube channel after the event. We can't see any of your faces or any noises that you make at home, so don't worry about that. Please do make use of the Q&A function. So look at the little Q&A icon on your screen and ask questions in there, and we'll answer them as best we can in the time we've got at the end. And we'll also be emailing you out tomorrow with a link to apply for basis and Neroso points. So that's everything on the housekeeping. We'll make a start now, and I'll hand over to Andy Cunningham.
Yeah, morning all. Thanks for joining us today. It's nice of you to turn up. So today we are talking late blight, and I am Andy Cunningham. I don't know if some of you might recognise me from some of our trial sites up and down the country, but I am now the technical manager for potatoes in the UK for Syngenta, and you might be pleased to know it's not just myself today. We're going to have a bit of a double act. I'll be setting the scene with where we stand as Syngenta and the challenge against late blight. We'll then bring in our application specialist, Harry Fordham, as Gus mentioned, to show us the importance of application around controlling late blight. And then I'll come back in and finish off around the effectiveness of our current blight fungicides that we'll have in our toolbox. And then finally, just as a bit of an encore, I thought we should just have a bit of a reminder of the other blights that can infect our potato crops. But without further ado, I thought let's talk about late blight and realise obviously it's an absolute nightmare if it can get into your crop, and we need to make sure that it doesn't get in. But I thought we should just go through some of the challenges that we face with this disease. Now, one of the main problems with blight is the way that it can evolve, and it creates what's called new genotypes, and they have their own unique challenges. Now, obviously there's a whole raft of different strains out there, but these are just three of the most dominant or the most important that we have. We've got the 36 strain, which is currently the most dominant strain in the UK. The fungicides we have currently don't really have a problem keeping it under control, but it's the fact that it's very aggressive and it's very fit, which means it comes into our crops sooner than it might otherwise have wanted to do, which means we have cost implications because fungicide programs have to start earlier. We've got the 37 strain, which has been around since 2016. The main problem with that is that it is fluazinam resistant. Now, that was a mainstay of a lot of late blight controlling programs. I think now it's getting a bit awkward to actually recommend it solely as a late blight product. It obviously still has its uses, both in terms of pink rot and powdery scab, but yeah, that one's keep our eye on it. And then the 6 strain, which has been around for a number of years now, but the problem with this is it gives blight the chance of evolving because it gives it possibility of sexual reproduction, which in no way sounds anywhere near as good as it should do. But yeah, that being around means that new genotypes are always going to be a potential risk, but we can cover that in a minute. Couple that with the imminent loss of mancozeb in this country. Obviously it's gone in the UK, but the loss of this is going to put pressure on them actives that we have. Now, mancozeb, just to remind you, has been linked with several health concerns at this minute in time, and it's been sort of identified as an endocrine disruptor. And I am hearing that some end markets are looking to make sure that mancozeb isn't used on any produce that they take from this season's crop. So it might be important to check your end users and their expectations on whether mancozeb is able to be used. And also the loss of diquat. I think it's really been felt now. We mentioned about the 36 strain coming in earlier, so fungicide programs have to start earlier. But the fact that waste piles are going to be harder to control, That's a main source of inoculum for blight, but also it takes longer for crops to desiccate. So fungicide programs need to go on for longer. So they start earlier and end longer. This all means that there's cost implications. So yeah, challenging times. But one of the good things that comes out of the AUDPC funding was the blight genotyping that Dr. David Cook at the James Hutton Institute does. And you can see this is a bit of a summary of the work that he's did last year. Like you can see, there was over 1,000 samples sent in from the blight scouts around the country in the UK, and then they were genotyped, which all means we have a very good understanding of what genotypes are out there, which helps us know the IPM measures that you are implementing are helping to keep the disease in check. So if we look at how the blight has evolved since 2003, this is some really good work that David Cook at that James Hutton does. You can see that that 36 strain, which I'm mentioning, is increasing in popularity because of its aggressiveness and dominance in our potato crops. So we need to keep an eye on that. 37, as I said, that fluazinam resistant strain, it's remained its population. It's still 9% in the whole of the UK, which still does make it awkward to be considering fluazinam. I'm not saying it won't act in any shape or form, but it does make it awkward to consider it for out and out blight control. I haven't mentioned the 13 strain yet, and that's quite interesting because it is now only 1% of the population. You look back to 2007, 2008, how dominant it was back then. And the problem with this one is it's resistant to another mode of action, or another mode active ingredient in the sense of phenylamides, which are a very important group of fungicides which have systemic activity. The fact that it's now only 1% of the population out there does give us that argument to possibly even look to use it more openly. The fact that the strain is still there still means we have to have a conversation probably about that, but the fact that the new IPM measures that are coming in, the use of different mode of actions and mixtures, means that we should be putting less selection pressure on that genotype, which possibly does allow phenylamides to be used again, the likes of methylaxyl-M, them sort of products. Then we come to the 6th strain. Obviously, I keep going on about that sexual reproduction. I'm sorry about that, but it just gives that possibility that blight can evolve. And funnily enough, that other, the one at the top in the grey bar, they are novel genotypes that only appear once when were genotyped by the James Hutton Institute. And it just shows you that blight is trying to evolve, and it just depends on how fit it is able to survive in the potato world. But then when we break it down to countries, you can see there's quite a variation. You can see that in England, the 36 strain is quite dominant, but when you look across to Wales and Scotland, that is definitely not the case. And particularly if you focus on Scotland as well, you can see that the other population is quite high. And then you look at also the 6th strain, which is allowing it to reproduce or change its genotypes, is quite high as well, which would suggest that there is more sexual reproduction going on in Scotland. So that's definitely something we need to keep our eye on and look to have longer rotations between crops to avoid that oospore soil infection, to keep that population of the others or the new genotypes evolving and getting a chance to have a foothold into the potato crop. Some other work that David Cook does is look at the sensitivity of the genotypes to the main actives on the market. And he does this by looking at the EC50, and that is the amount of product or the amount of active that is needed to control a 50% of a blight lesion, which is inoculated. Bit of a spoiler, I suppose. There's nothing too scary here. If you look at the levels of active that's needed to get the EC50 against that 6, the 36 strain and the 37 strain, is very low compared to the actual field rate of each of these actives. And we've got some like mainstays of the active market, thiazofamide, obviously imidacloprid is in there, which is in REVUS. You know, these are all mainstays, and even oxythiopripylene, OXTP, very potent, and there is nothing to suggest there's anything going on regards to reduced sensitivity to the blight strains or the main dominant strains at this minute in time. So that's really good. So just to summarize David Cook's work, obviously a lot of the populations of the blight genotypes have been exposed to the active ingredients over several years, and there is no evidence that there's any erosion of sensitivity to them actives. So that's really good. And also there's no cross resistance within mode of actions. So that's also good as well. So CAA fungicides all seem to be as active as each other. And it just helps to support the benefits that, the growers like yourselves are following the FRAG guidelines to make sure that blight doesn't get a chance to evolve and get more resistant to these actives, which are going to be under pressure with the loss of mancozeb. But I mentioned the IPM measures, and I don't think it hurts to just remind ourselves of the good practices that you are doing. Good hygiene in the crop. So if you're using home safe seed, checking for signs of tuber blight, or using certified seed, which has a very low tolerance to tuber blight as well. Knowing what varietal resistance you have. I know a lot of the potato crops that you grow, you don't have, you're subject to what the end market wants. So you need to be aware of what varietal resistance there is, both in terms of foliar blight and also tuber blight. Extended rotations, and that works both in terms of controlling the main source, which is through volunteers. So reducing volunteers, you can get a chance to control them between crops. But also I mentioned about the oospore activity, and that is how you get their new genotypes. So extending rotations means the oospores in the soil become less viable, and you should get less new genotypes coming on. And then use of decision support tools. Blight comes in much earlier than it used to. Obviously, we used to have the Smith's period, which is now the Hutton criteria, but using products like or apps like the Blight Cast Alert will help growers like yourself keep crops in a protectant scenario rather than going down a curative scenario. But then obviously that brings in fungicides. It's the inevitability of it all, I suppose, and how important products like REVUS are performing against the current blight strains that we have in the market. Now, this was our focus with our trials this year. We did a lot of work at Derbyshire with Eurofins, and we were looking at the elusive 3D90 nozzle, which Harry's going to talk to you about in a minute, and using our fungicide Am4+, which is mandipropamid and difenoconazole. You'll also be aware, or hopefully be aware, that REVUS's control is notoriously improved with drift retardants. So what we wanted to do is to explore whether all drift retardants bring the same benefit as we find with Interagro's Crusade. And also we wanted to, as I mentioned at the start, explore the aggressiveness of that 36 strain and just how effective are products like REVUS against it, and how do other products that we have in our toolbox against it as well. So this is where you get a bit of a break from me. I will bring in Harry, who's going to talk to you about nozzle selection and all the things that come with that. But yeah, hopefully you can go into it a bit more competent than I will, Harry. So I will stop sharing.
Morning, everyone. Thanks, Andy. Really good intro.
Problem.
I'm sharing, Andy. Don't worry.
Oh well, that's sorry.
It's all right. Yeah, morning, everyone. Thanks, Andy. Really good, good context given there, and explanation as to where we are in our blight control world. What I'm going to talk to you about today is the application trials that we have done over the last 3 years in potatoes, using different application techniques and adding in different tank mix partners. So as Andy said, we've done lots of work looking at drift retardants and how they fit in with our recommendations. So over the last 3 years, we've done some really key application trials, and they have sort of 5 key objectives. And part of the catalyst for this was our nozzle manufacturing partner Hypropentair discontinued the potato nozzle, and the potato nozzle had been a stalwart to the potato application campaign and for many growers around the country when in their blight protection campaigns. So we had to we felt the need to look into another suitable option for potato blight control. And as we know, we're under increasing pressures from regulatory partners to look at drift reduction techniques and whether drift reduction can work in many circumstances and increasing drift reduction. So we wanted to establish if 90% drift reduction or 4-star LERAP rated nozzles provided adequate or good control of foliar blight. Do we have any difference between our new Syngenta 3D90 nozzles and other well-known 90% drift reduction nozzles such as Leckler nozzles? When we add in the drift retardants such as Sterling or Crusade, does that increase or decrease the efficacy of these nozzles? What effect does that then have on the spray deposition within the crop? And by how much does using these nozzles potentially reduce the efficacy versus conventional finer droplet nozzles that the potato nozzle has been historically? So when we do our trials, we do them in collaboration with Eurofins up in Derbyshire. We do them inoculated trials, so we are trying to put these under an immense amount of pressure to ensure that we get the best level of or the best insight into the level of control that we can get. Each treatment is replicated. Each plot is 6 rows wide and 11 meters long, so we don't have any sort of pressure issues, and we've done it with a mounted Amazon sprayer that's got an accurate dosatron system to ensure we're applying at the correct rate and applying as close to farm standard as we can. Now, 2 years ago, when we did the trial, we used did the first 2 applications of Kurzate plus Zorvec, and then the following 6 applications were a REVUS plus Sterling mix, and that then was looked at with a potato nozzle, a Leckler ID3 nozzle, the Syngenta 3D90 nozzle, and a flat fan 110. So the potato nozzle, as you all know, is angled and a medium droplet, but no drift reduction capability. Hopefully I don't need to introduce a flat fan to you, but it's a vertical finer droplet nozzle. The Leckler ID3 is an air induction vertical nozzle that offers 90% drift reduction, and the Syngenta 3D90, which I'll elaborate on shortly. You can see the replications through the trial. And again, a cool picture of Eurofins spraying the trial, and you can see the untreated plots quite clearly at this top end where the blight's getting in. And you can quite nicely see within the trial some nice different application changes. So you can see where certain applications have worked better than others as we go along the plots on the left-hand side there. So the 3D90 nozzle, what is it? Why is it so good? Why are we so proud of it? It is a angled nozzle similar to the old 3D nozzle. The angle is greater though, so it's a 55-degree angled nozzle. And the key reason behind that is it has a coarser droplet, and because of the coarser droplet, they're heavier. They require more momentum to carry on in a straight line. And as a result, we need to angle them more to ensure we hit both the front and back of the target. And back of the targets are notoriously the trickiest bit to hit. But because of all the research we've done into this angle, we are very confident in its abilities. It's a pre-orifice nozzle, so it is an air induction, and it gains its drift reduction through the pre-orifice technology. This makes it compatible with pulse width modulation sprayers, as well as conventional sprayers, so it's as flexible as we can be. And also it has this snap lock fit cap on top integrated into the nozzle, so it's an all-in-one mechanism. So will hopefully spare your thumbs and knuckles from grazing on the boom when installing the nozzles. As we know, when installing new nozzles can be tricky. It will have 4-star LERAP rated drift reduction capability, and I think I said it this time last year, but due to manufacturing difficulties, we didn't launch last year. However, we'll hopefully be launching it this year, and you should hear more about it towards the end of March, beginning of April. How does it perform though? This is the key question I'm sure you're all dying to hear the answer to. So what we've done is when we sprayed our straight REVUS, we put in some Helios dye, and you can see it works as a really nice glow in the dark illustrative image of how the product performs once it's released from the nozzle and onto the leaf of the target. And you can see we have 4 different pictures here, and we have several slides all in the same format. So I will take time to explain the format of the pictures. So on the top left here, this is the growing point of the potato. So the top of the potato. Here we have the leaf layer just below that, which we've designated the top. We have the middle of the crop here, which is notoriously pretty tricky to hit, and then the bottom of the crop down here. Now, these are the 2 that are very difficult to hit because they're obviously shaded by a dense canopy above them. And when you use a finer droplet nozzle, such as the potato nozzle, we struggle to get the momentum of the droplets and the penetration through the leaves down into those lower layers. And it's key to remember with these middle and bottom layers can be quite a nice little atmosphere for blight to creep in. We have higher humidity, generally less airflow. So the microclimate within there is potentially pretty risky for blight. When we look at the Leckler ID3 nozzle, just with straight REVUS, you can see because of the coarser droplet, they're quite visible and bigger on the growing point and the top of the leaves. But we're actually getting more penetration down through the middle into the bottom of the leaves. When we look at 3D90, again, nice big droplets, very drift risk preventative, and you can see but nice even deposition across all the leaves at the growing point in the top, and again more penetration into the middle and down into the bottom of the plant, giving us really good levels of control. When we've added in a drift retardant such as Sterling or Crusade, you can see that on the potato nozzle where we have a fine droplet, it's made those droplets bigger and given a bit of a increase in coverage. And likewise on the top, when we get down into the middle and the bottom, because of the bigger droplet size owing to the drift retardant that we've added in, we're getting more application down into the middle and the bottom of the crop. When we look at the ID3 nozzle, again, you can see we're getting nice big droplets, even sized droplets at the top and the growing point, and really good penetration down into the middle and the bottom. And again, likewise, 3D90, we're getting that nice effect of evening up droplet size at the growing point and the top, and getting really good penetration and coverage down into the bottom. And one thing that's key to remember with these drift retardants is what they tend to do is take the extremes of droplet sizes out. So with finer droplet nozzles, such as the potato nozzle, it'll make the VMD average slightly greater because it takes away the very small droplet sizes that those nozzles are very prevalent to have. And that tends to be how it helps to reduce drift or reduce the risk of drift. But that's great. We've talked about drift and that's important to think about. But actually, what does that mean in terms of disease control across our trials? So here you can see the application timings with the 5 blue stars of REVUS, both with and without the drift retardant. And then the blue line here is untreated. And you can see under high pressure by the end of August, more or less completely dead. But if you zoom in on the important part of the trial here, you can see that we have 4 distinct lines at the top. So the green, yellow, dark red, and orange. And nicely for us, the green is the 3D90 just with straight REVUS, and all the ones above it are also straight REVUS applications. So in a straight REVUS situation, the 3D90 is performing better. When you add in the drift retardant, you can see below that we've got the potato nozzle and 3D90 are aligned and performing as well as each other, and then closely followed behind with the Leckler ID3 and the flat fan. So we're really encouraged by this, and this gave us some really nice data to build on our 3D90 blight application messaging. And here you can see the area under disease pressure. And again, what you want here is the lower the bar, the better the result. And again, 3D90 outperforming the rest of the competition. Last year, we did a very similar setup trial. What we thought, though, is we'd look at a different co-formulated mix that we have at Syngenta with Am4+. So that is mandipropamid and difenoconazole. to investigate the impact of formulation on any of those factors. We took the potato nozzle out of the protocol. It's unfortunately now it's gone. There's none in stock, so there was no point in trialing it to give you information on something you can't use. But we again used the flat fan, Leckler ID3, and the Syngenta 3D90 nozzle. Similar setup with 2 applications of Kurzite and Zorvec, followed by 6 applications of Amphor Plus, both with and without the drift retardant. And then here you can see similar layout. And when we applied it, you can see the 6 different timings. The red is the untreated. And again, you can see by the beginning of September, we're almost fully infected. When we do the zoom in on the important results, you can see here, what was lovely from my perspective is twofold. Again, 3D90 performing extremely well without the drift retardant, but even when you add the drift retardant in, 3D90 performing exceedingly well, better than the other nozzles on offer. ID3 not doing badly at all either. So 3D90 is a very good option in our potato trials, and you can see we can put a nice little tick next to the 3D90 as a significant result over and above other results compared to the flat fan. And here you can see all of these aligned in together with our, we'll call it the 3D90 plus drift retardant line of control, and 3D90 offering fantastic levels of control. So conclusions are, Amphor Plus was doing a great job of controlling late blight. The addition of the drift retardant had a positive and significant impact on levels of disease control, and 3D90 was the best choice in achieving the best level of disease control, and the flat fan was poor compared to the others. So from our perspective, 3D90 will become our recommendation as soon as our colleagues at Hypro manufacture them, which should be very shortly, closely followed by the Leckler ID3 in compromised spray conditions. Please encourage you to, can I please encourage you to ask any questions through the Q&A function on the Zoom options, and we'll come to those at the end. I'm now going to hand back to Mr. Cunningham, who will take you through the rest of our blight trials.
Lovely, well done, Harry. Thank you for that. So inevitably, we do come to fungicide control. I suppose it's a bit like when you go and see your favourite band, isn't it? They always save the best song till last, don't they? So, or sort of, maybe not. But what we saw from Harry's presentation was the benefits of adding then drift retardants with Amphor Plus, and this is definitely something that is the case with REVUS as well. In fact, it is Syngenta's recommendation that it is done or applied with Interagro's Crusade or Sterling, as Harry used in his trial. But what we wanted to look at was the benefits of drift retardant, obviously, and there are 2 reasons why that we do this. Is because obviously drift is reduced, so you're getting more of the product where you want it, but it is also because it improves spray deposition, as Harry showed on his slides, to maximize the performance of REVUS. But are all drift retardants the same? And this is exactly what this trial was hoping to achieve. You can see we used a variety melody, so it's a rating as 4 for foliar blight, and it was inoculated with 37 and 36 strain genotype. So you can imagine the levels of blight that we ended up getting in this trial. There was 12 sprays in total. 6 of the main treatments were applied where, well, the green section. So that was around that stable canopy phase with cover sprays at the start and end of it. But like I say, the main timers were applied in green. And if we look at the actual treatment list, we used Infinito as a standard to compare with REVUS, which has got the fluoropicolid and the propamocarb. So that's zoospore activity and also systemic activity with propamocarb. So that's an ideally suited probably throughout the program, but especially at that rapid canopy phase. REVUS has translaminar activity and is locally systemic in the leaf, so it will grow as the leaf grows with it. And it also helps to get to that tricky underside of the leaf. So it's a very good product again throughout programs, but especially in that rapid and also the stable canopy phase when you're trying to get good coverage on the leaf. But as I said, it was mainly about the drift retardants, and we know the mix with Crusade is what we would recommend, so because we know that works really well. But we are looking at 4 other drift retardants, and that's why I've coded them A to D. And I've done that because we can't exactly change our support with 1 year's data, but if we get the repeat positives that I will show you now, that may change. But we'll have to see how things perform in this season's crop. But let's have a look how they performed, and hopefully we can make some conclusions from it as well. So this is how disease developed through the season. You can see that when it came in. There was a big upward trend to get into full defoliation with blight. And it just shows you also that Infinito and REVUS have effective control. I put in the final application that was applied on the 2nd of September. So blight was coming in, but then after them treatments are finished, blight kind of romped away as well. But I think it's probably easier to compare the treatments without the untreated squeezing them together. So if you first bring Infinito, you don't know how that's compared to REVUS, which you might think that's surprising. You know, we crow about how good REVUS is, and it doesn't look too dissimilar to how Infinito is performing. But you add in Crusade, and control looks to be significantly improved, which we'll get to in a minute. And this is where we start getting interesting, because we start bringing in the other drift retardants. So we look at A, drift retardant A, that was comparable, and so was B. The drift retardant C was off the pace, which does start making you question, are drift retardants all the same? And D, comparable again. So 3 of the 4 look pretty decent. And if we remove the untreated data, we can really see them differences between them drift retardants. Again, to get the best out of REVUS, you really do need to get a drift retardant in the mix to improve that spray deposition onto the leaf and get that full canopy. Because when you're adding in, if I'm just looking at Crusade, you do get sort of a massive 52% increase in the level of efficacy, with only that drift retardant C not performing to the same levels as A, B, and D. So you can see that not all drift retardants are the same, and you can see why we are exploring other drift retardants, and definitely not looking to change our recommendation until we can categorically support which drift retardant is consistently achieving the levels of control that we believe you need to with REVUS. So we're moving on from drift retardants to actually all the different actives that's on the market. This is what we call an intrinsic trials, where we look at all the actives on the market and see how they compare against dominant strains of blight, which includes that 36 strain. I do like this trial because there's almost no hiding for any product. There's no oversprays before or end. It is same products applied all the way through the season. You can also see down there the 3rd point, we want to look at the challenge of losing mancozeb and the hole that could bring in our blight programs as well. So as I said, it was inoculated with that fluazanam resistant 37 and the aggressive 36 strain. There were 12 applications in total, all the same, and again was a melody, so relatively susceptible to blight. So it should be a good test for the treatments that we'll talk to in a minute, because I think before we get to them, we should really talk about resistance management guidelines around REVUS, particularly, and also good blight program management with FRAG guidelines. So just as a reminder, with any CAA fungicide, but in particular REVUS, you can apply 6 applications of REVUS so long as you put it in with a mix of fungicide with a different mode of action. If you apply REVUS on its own, you can only use it 4 times. So you can see where it's going there. It wants you to mix it in with another mode of action to encourage that low selection pressure on the blight strains. And then in green, you can see that we've got no consecutive applications of CAA fungicides. So that includes the likes of benthiobalacarb and dimethomorph. But yeah, just in general though, try and be preventative, not curative, because as you see, when blight does come in, it is hard to control. I'm sure you know that. Using full rates, so again, not leaving the door open for blight to get in, and achieving good coverage. Obviously taking on board what Harry was saying with nozzle selection, but also the different mode of actions that these fungicides can bring will allow you to get good coverage to the underside of leaves, and also systemic activity as you are going through that rapid canopy phase. And then anti-resistance strategy. You know, I mentioned at the start about using co-formulations, using mixes of different mode of actions, but also looking to use multi-sites, which basically means mancozeb at this minute in time. So let's have a look at the treatment list. And like I say, after all that, we made 12 applications of the same treatment all the way through the season. So, but obviously, I'd like you to give me a pass on that, because we are actually, you can see how each active is performing against the blight strains out there. If we just try and go through them individually quite quickly, we've got REVUS, mandipropamid, translaminar activity, and also that locally systemic with that crusade. So that's our recommendation with how REVUS should be used. Proaxinil, UPL's propamocarbon cymoxinil, so systemic and translaminar activity there. Valbon has got mancozeb in it, that along with benthivalcarb. The Silus is a straight benthivalcarb. It does have quite a bigger proportion, almost 2/3 more benthivalcarb. So that would be a good test to compare against REVUS. I'll drop down to an Everin first, because that is a mechatradin, which is BASF's product. But then with Percos, they've added in the CAA fungicide of dimethomorph. And finally, Shincom, which is a amisulbron. So that's a zoospore active fungus, not necessarily majoring on foliar blight, but towards the back end of your programs, you are looking to make sure that zoospores don't get down into the soil. And that's exactly where Shincom would be used. But as I said, I also wanted to look at the implication of losing mancozeb. So you can see the top treatment in green had no mancozeb at all. We look to mitigate the loss of mancozeb to basically substitute in systemic, translaminar, zoospore, contact acting fungicides in the hope that it might mitigate the loss of mancozeb. There is a difference. It's very rough maths. It's around 340 to 350 per hectare as a program, one in green, and then around 27, 30 pounds cheaper with the mancozeb treatment. So let's hope that spending a little bit more can mitigate mancozeb, but let's look how things performed. So as I said, it was inoculated, so you'd like to think the level of disease was good. I brought in the REVUS treatment first, and you can see that there is a significant increase in level of control, but obviously you don't know how that compares with the rest of the treatment, so let's bring them in. And you can see, if you look around where that REVUS line was, there are mainly 3 treatments in there. Well, there is 3 treatments. One is the REVUS one that you saw at the start. The other 2 contain mancozeb. One is the Valbon treatment, and the other one is the mancozeb program as well. So you can see that mancozeb is a product that has potent activity against tuber blight, late blight, as well as having that anti-resistant strategy as well. So it is going to be a product that's going to be hard to mitigate. Now, looking at the area under the disease progression curve, and that basically means how the disease progressed through the season. And it takes, and you can see that if we look at all the treatments, they all had a significant level of control, which is good. But if we remove that untreated, you can actually see the differences more clear between the treatments. And I'll bring in that REVUS line, because you can see that the REVUS, although statistically very well, it's comparable to Valbon. Yeah, it's only Valbon, but numerically, it is the best treatment within that trial. And if this is backed up from data from previous years as well, if we look at what happened last year, there was only 2 common treatments from this year and last year, or the last year and the year before, should I say. And you can see when compared to Valbon, which was the main comparison, I guess, to REVUS, there was a nearly 30% better level of control with REVUS. So you can see that mandipropamid is a very good CAA fungicide at controlling late blight. Now, other worthy mentions, we got an Everin, which is that mechatradin product from BASF. It's bringing up the rear, sadly for it, along with Shincom, which we'll get to in a minute. But you can see the additional dimethomorph has improved control, but obviously compared to REVUS, it's possibly not to the same level. I did mention amisol bronze strength is zoospore activity, and unsurprisingly enough, the level of foliar blight in that treatment was quite high. I did say that Bacillus was an out-and-out CA8. It performed pretty well, but compared to mandipropamid, it does look a little bit off the pace, with REVUS significantly performing better. Now, just focusing on that program approach, that £27 per hectare didn't do too much to keep it in line. You can see that the mancozeb treatment was significantly better than the non-mancozeb. So, like I said when I was talking to the result, the fact that it's a multi-site is really good for resistance management, but it also shows that it is an effective product and it is going to be hard to mitigate its loss. So yeah, I think it's an R&D or manufacturer's responsibility to try and find another multi-site out there that can ensure that we keep the current chemistry, which obviously at this minute in time look to be effective as they are. So we will have to double our efforts, basically. So just some take-home points around REVUS, and basically it looks to be the most inherently active and most potent against the common and aggressive blight strains on the market in the population of potatoes. REVUS looks to be the most effective CA fungicide, so definitely aim to get that in your program, but get it in a mix because it'll make the best use of it under the FRAG guidelines. But my recommendation would be to obviously use it throughout the season, but especially through that rapid canopy phase and also the stable canopy phase as well. Now, I did mention at the start about the other blight that can affect your potato crop. I think it's important not to forget that it can come in. It's called Alternaria. For those of you who've not heard of it before, I'm sure you have. It can affect potatoes throughout the season, but it does tend to start around late June when conditions warm up. And it's not as severe as late blight, but it is tricky to diagnose. And typically it's not controlled with what you would call typical late blight programs. So frustratingly, if you don't apply a product that's active on late Alternaria and then you see it, it's generally too late because chemistry that we currently have is more prophylactic rather than curative. Now, Alternaria is a fungal pathogen. It mainly survives on plant debris, and if left unchecked, can cause up to 30% yield loss. So it's a significant disease. There's two different species, the Solani and Alternata. It's the Alternata that tends to come in first, but the Solani is the more aggressive, and it will cause these dark brown spots, and then eventually they'll cause these concentric rings. So they are quite typical in their symptoms, but they can be confused with nutrient stress and is hard to diagnose. In fact, we do sponsor some work at NIAB to diagnose when Alternaria is actually in crops to help agronomists and growers target the disease, basically. And then it lifting of the tubers, it can get onto them and it can cause a dry rot in store. So it is an important disease to keep under control. Now, this is what it looks like in the field. Unfortunately, Syngenta does have a product in the form of Amphor Plus, which is mandipropamid, which can look after the late blight, but it's a difenconazole that's in Amphor Plus that keeps it in check. This is some data. To be fair, it is pretty old, but it is very effective. Like I said, it's a difenconazole that's protecting against Alternaria, and it is only Amphor Plus that can deliver a 150 gram of difenconazole versus other difen versions that's on the market that can only deliver 125 grams per hectare. And you can see that with that extra 25 grams of difen, you're getting an improvement in 37%-ish control. So I'd like to think I'll be able to produce some fresh data for you next season, especially with the price of nitrogen being where it is. There might be a temptation to maybe cut back on rates, and it's this slight nutrient stress that can encourage the disease to thrive. So it's definitely one to keep your mind's eye on as and when these conditions occur, when it starts warming up. And then just a reminder around the Amphor Plus, because it's got mandipropamid in there, it does come under the FAG guidelines that we have to abide by the CAA fungicide. So like as I mentioned, not having consecutive 3 applications, and this will add into how many mandipropamid applications you can make. But other than that, I've taken you through the blight, and if you've got any questions, I'll try and answer them for you. And everyone, and hopefully Harry can join me as well.
Okay, yeah, thanks for that, Andy and Harry. That was brilliant. So, yeah, like Andy says, if you've got any questions, do post them in the Q&A box. So, first question goes to Harry. Are CRD interested in the drift reduction work, and is this something that could be part of labels going forward?
Good question. So CRD in all registrations we'll look at drift mitigation technique, and that might be through Lear rated nozzles, or it might be through buffer zones, or a combination of the two. Whether they would like to use drift retardants as a approved drift mitigation technique is still being discussed. So I can't comment on that, but what I do know is, for example, in the Netherlands, last year they approved a drift retardant to be considered as a drift reduction technique that added what they call 5% to their drift reduction technology. So if you had a 90% drift reduction nozzle and you added this drift retardant that was called Squall, that is only available in the Netherlands, but it's called Squall. If you added that into a 90% drift reduction nozzle, you would then be up to 95% drift reduction rating. So I think our regulatory colleagues are looking at it, but I don't know anything about it happening in the near future yet.
Okay, great. Thanks for that, Harry. Next question is for you, Andy. There was some differences between the drift retardants in your work. How can people tell, which ones are likely to work? Is there formulations in common, or actives, for want of a better word, in common?
Good question. It's not one that is probably apt for me to answer. It's something I'll have to get back to you on that one. Is there a way that we can answer questions at the end and send out the answers?
We can email them out to the people.
Yeah. Like the reason, there was no real reason why the C should have performed as bad as poorly as it did compared to everything else. So there might be more going on than the actual formulation of the drift retardant. But yeah, I'll get a better answer for you on that one. Okay,
another question for you, Andy. Does Amistar have any effect on Alternaria?
I believe it does, yes. But as I haven't got the data on that one, but yes, it does.
Okay, yeah, we could maybe follow up with that then,
yeah.
And then another question was, how do we sign up for Blightcast? But that's the one I can actually answer.
Oh, well done.
Easy enough. You just Google it, type Blightcast into Google, it'll bring up with the Syngenta homepage, and you sign up for it there, and you'll get daily updates on that, I believe. Okay, we've got another. When using REVUS in a tank mix, would you still recommend the use of a drift retardant, e.g. REVUS plus cymoxanil?
We did do some trial. We've got a product called Carriol Star, which has got cymoxanil in it, I think, and that performed similarly with the benefit of drift retardant. So I would say yes. Okay. Because you're getting the benefit of the drift, so it's keeping the product where it should be, but also that spray deposition that Harry mentioned. I think drift retardants don't just necessarily improve REVUS. I think generally they are useful in fungicide programs anyway.
Brilliant. Okay, well, it's 1 minute to time, so we'll end the session here. Thank you very much to Andy and Harry for that wonderful presentation, and thank you all for joining. And we do hope to see you tomorrow for the biostimulant in potatoes session, and on Friday looking at sustainability. So thank you all again.
Thank you.